Hello everyone, that's Mohammed Yaqub, and this is another video on the STM32 Nucleo tutorial series. And today's video is going to be about using serial communication, or UART. UART has got two pins, TX and RX, and usually a common ground between them. And you connect TX of the first device to RX of the second device, and vice versa. In my demo today, I'm going to send data over from my STM board to PC to a serial terminal that I have real-term through this USB. Because by default UART2 of the STM Nucleo is connected directly to the ST-Link UART. Unlike the STM32 Discovery board where UART is connected to the external pin, if you want to connect an external UART device instead on TX and RX pin, you can still do that, but you would have to undo some of the soldering bridges. According to the reference manual, if you want to connect an external serial communication, you'd have to undo 13 and 14 and solder 62 and 63. These are shown in here, so you'd have to desolder these 0 resistors and soldering bridge 13 and 14, and you have to solder 62 and 63 on here. If you did this, then you can take the UART output on TX and RX pin. Otherwise, TX and RX are output through this USB. Okay, let's make a start and set up a new project in CubeMX. And on CubeMX, click on a new project and select the right chip. The easiest way is to use the board selector, and it's the Nucleo 64 F4 series, and it's the 01RE. And this is the default pinout of the board. I want to clear all the pins and enable them my own, so go to pinout, clear pinout, and hit yes. And I want to enable the LED on the board, TBIU output, and the push button as the TBIU input. And now I need to enable my UART, so scroll down till you find UART. So I'm going to enable UART2, and the mode to asynchronous, and this should enable 2 and 3. And these, as I mentioned, are internally connected on the board, connected to the ST-Link USB directly. So we don't have to do any external connections. So that's it for the pinout. Let's go to configuration and see if there is anything we can change. So go to UART2, parameter settings, baud rate, I'll leave it as it is. I'm going to enable the UART2 global interrupt because I'll be using DMA for receiving data. So click on add, select DMA RX only. What this would do is that on receiving data, DMA will take the data straight to memory, and then it will interrupt because I enable this one. Okay, so this DMA, the data width to byte and the mode to circular and memory increment. Memory increment because I'm using an array for the data, and for each byte it receives, it will increment the memory so that next time it will store in the next location memory. And circular means that if we receive the full data, next time it will start again from the 0 position memory. If I kept it normal, it will keep incrementing memory endlessly. So that's why we use circular in here. These are all the settings for UART, so click OK. Oh, sorry, I know perhaps you don't see this side of it, so memory increment is this one. And that's all we need to do in CubeMX. So we're ready to generate the code. Click on generate source code icon. Select a location to store your project files in and give the project a name. So I'm going to call it UART video. Select the right IDE, so MDK ARM v5, Keil Macrovision, and click OK. And now once the source code is generated, click on Open Project and this will take you straight to your IDE. In Keil Macrovision, expand this project folder, expand the application user folder and open the main. And first thing I want to show you here is how to transmit data. So to transmit data via UART, you simply use hull UART transmit function. So I'm going to use this in here and transmit data every second. Hull UART transmit. And this function takes 3 parameters, I believe. The UART handle type diff, so it's UART2, and the ampersand sign because it expects a pointer to that. This handle type diff is defined by CubeMX and given the name it's UART2. And that's what we use in here. The next parameter is the array that holds the data. So I need to define this in here. Unsigned 8-bit array. I'm going to call it my TX data. I'll give it size of 13 perhaps, and the data is just hello world maybe, with the carriage return. And these are 13 bytes I believe, so yes they are. And I need to transmit this. So just pass the array name correspond to a pointer to the array, and then data size to 13, and timeout to just 10 milliseconds should be more than enough. And I'll toggle my LED as well, just so that I can see it on the board. HAL GPIO toggle pin on port A and pin number 5. And I'll put a delay of 1 second, and that's it. That's how to transmit data. So now let me compile it, load it to the board, and then we're going to go to our serial terminal, and we should be able to see this transmitted there. Okay, compiled successfully without any errors. Now let's load it to the board, and then we're going to go to real-time serial terminal. First, click on the reset button on your Nucleo board, and let's go to real-time. You can use any serial terminal you have. I've got T-term and real-term, but I prefer to use real-time, so go there. And on here, go to port tab and select the right port. It's COM port 3, that's the only one I have available, the one that corresponds to the Nucleo. And the baud rate I set it to 115/200 in the STM, so this one has to be the same. And click open. Okay, I'll just clear this out. Yeah, and I get my hello world here. Let me restart my Nucleo just to make sure that the noise I got at the start is correspond to nothing. So I'll clear this out, restart my STM. Very good. Okay, I'm getting the hello world message correctly. And now let me show you how to receive data via UART. And we're going to use a DMA as I mentioned in CubeMX for this. And to start receiving data via DMA, use a function called HAL UART receive via DMA. And this function takes few parameters. The first one is the UART handle type diff, so it's UART2, and a pointer to that. And second parameter is the RX data buffer, so I need to define a variable for that. Similarly, unsigned 8-bit integer. I'm going to call it my RX data, and I'll give it size of 11 data points. And I need to pass this, a pointer to this array, which is just the name of the array, to here. And the size, I'm expecting 11 data bytes, 11 bytes. And the last parameter is, no, that's the last parameter, size of the last parameter. Next thing I need to do is I need to define the UART receive complete callback, so that whenever I receive the full 11 bytes, it will interrupt, then I can read them and do whatever I want to do. And what I'll do here is just I'll echo them back to the terminal. So to define the callback function, go to functions and then expand UART. There must be a function called RX complete callback. That's the one, RX complete callback. Copy it to your main, but without the weak objects. So just copy it till void, and we'll define it in our main. We'll define it in here, and you can put your code in here. So when I receive the full 11 bytes, I want to echo them back. So I'll use the transmit function again. So I'll disable this one from here. So I'll cut it and put it in my callback function. And I want to send the RX data back, and there are 11 bytes. And that's all I need to do. So, so let me compile the code and load it to the board and back to real term. So in real term, the only difference here will be, so I'm going to clear the window and go to display setting, and I will enable the half duplex. And what this will do is that the data I send will appear green in color, and the data I receive will appear in yellow, so that I can distinguish between them. So I will open the port again. Let me reset my Nucleo board first. I'll open the port, I'll go to send, and I'll send hello all with the carriage return, and these are 11 bytes in total, and I'll send them. Let me clear this out first. So when I send it, appears in green, and mine appears in green, and the one I received back from this team appear in yellow. So perfect, it's working okay. And that's all I want to show you today. So if you like the video and want to see more videos like this, don't forget to like and subscribe. Take care, and I'll see you next time. Bye.